Question 1, we start by being asked to calculate the number of toads at the start of the study. So we will be substituting t is 0 into the expression for capital N. It's going to be 900 e to the 0, which is 900, over 2 times e to the 0 plus 1, which is 300 toads. In part B, we need to find the value of t when there are 420 toads. So we're being asked to solve 900 e to the 0.12t over 2e to the 0.12t plus 1 is equal to 420. I will start by cross multiplying to get 900 e to the 0.12t is 840 e to the 0.12t plus 420. So this means that 60 e to the 0.12t is 420. Dividing throughout by 60, we get that e to the 0.12t is equal to 7. So 0.12t is ln of 7. So I divide by 0.12. And this gives an answer of 16.22 years. Finally, in part C, we need to explain why, according to the model, the number of toads will never reach 500. We need to consider the long-term behavior of capital N. So we say that as t tends to infinity, capital N tends to 900 e to the 0.12t over 2e to the 0.12t. In other words, we say that as t becomes larger and larger, these play all the role and the plus 1 is insignificant, so I ignore it. And this is 450, which is the upper limit, and therefore the population can never reach 500. So population can never reach 500. Question 2, we need to find f of g of e squared. It's a composite function, so I will first apply g and then f. So this is f of 5 over 2 ln of e squared. Now ln of e squared is simply 2, so it's going to be f of 5 over 2 times 2, which is f of 5, which is 12 over 5 plus 1, which is equal to 2. In B, we need to find f inverse, so I will start by saying y is 12 over x plus 1. We will interchange x and y, so wherever we've got a y, we put an x. Whenever we have an x, we put a y. And now I'm trying to make y the subject, so xy plus x is 12. So xy is 12 minus x, which means that y is 12 minus x over x. So we have that f inverse is 12 minus x over x. We also need to give the domain here, so I need to sketch f of x. So we know that f of x had an asymptote at x is minus 1, because when x is negative 1, we've got division by 0 and the function is not defined. So at x is negative 1, we have an asymptote. And we also need to consider the position of the horizontal asymptote. So for the horizontal asymptote, we consider the behavior of y as x tends to infinity. It's obvious that as x tends to infinity, y tends to 0, so the x-axis will be an asymptote. We also know that when x is 0, y is 12, so we've got the cut on the y-axis. So the graph looks something like this. I haven't yet incorporated the restriction we had. we were told that f of x is defined for x greater than 0. So it means that it's only this part of the curve that I'm interested. So this is f of x. So I see that the range of f of x, the output, is between 0 and 12. And we know that the range of f is the domain of f inverse. And therefore, when I come to find algebraically an expression for f inverse, I also need to provide the domain, and the domain is between 0 and 12. In part C, it says, hence or otherwise find all real solutions for f inverse of x is f of x. So I could start by equating what we have obtained for f inverse with f of x. So we have that 12 minus x over x is equal to 12 over x plus 1. I will cross multiply to get 12 minus x times x plus 1 is equal to 12x. So let's expand the left-hand side. It's 12x plus 12 minus x squared minus x is 12x. The 12x simplifies. I'll collect everything on the right-hand side to get 0 is x squared plus x minus 12. I will factorize this into x plus 4, x minus 3. And we get that x plus 4 is 0 or x minus 3 is 0. So x is 3 or x is negative 4. However, we need to bear in mind that f of x can only accept positive values as input. So the negative 4 that we have obtained here needs to be rejected, since we need x to be positive, and we are only left with one solution. The solution of x is 3. An alternative would be for you to realize that solving f inverse of x equals f of x is equivalent to solving f of x is x. So we've got f of x is x. This sometimes leads to a simpler equation which you can solve. You've got 12 over x plus 1, that's f of x being equal to x. I will cross multiply to get 12 is x squared plus x. It leads to the same quadratic, which we still need to solve via factorization and reject one of the solutions. In question 3, part A, we need to find an equation that links log of y with log of x. I will start by finding the equation of the straight line here. So the gradient is simply y2 minus y1 over x2 minus x1. So it's 4 minus 0 over 0 minus 6, which is equal to minus 2 over 3. So I can also observe that the y-intercept is 4, and therefore log of y base 10 is minus 2 over 3 log of x base 10 plus 4. That will be the equation that links log of y with the log of x. And then hence or otherwise express y in the form px to the q. I will actually start with the proposed form, y is px to the q. The only way of bringing logs into the game is to take logs of both sides. So log of y base 10 is log of px to the q base 10. Now the right hand side can be written as log of p plus log of x to the q all base 10, which can be further simplified into log of p base 10 plus q log of x base 10, and that's log of y base 10. So I can now compare what I have with what I obtained in part A. So we can see that the minus 2 over 3 is the q, and then the 4 is the log of p base 10. So I can simply state that q is minus 2 over 3, log of p base 10 is 4, and therefore p is 10 to the 4, which is 10,000. So the only thing missing is for me to write the full expression. We've got y is 10,000, x to the minus 2 over 3. In question 4, we need to find f dash of x, and I will do that by applying the quotient rule for differentiation. So we differentiate the top, which is 2x plus 5 all squared, so we get the power down, we deduct 1 from the power times the derivative of the bracket, and we keep the bottom, minus keep the top, 2x plus 5 all squared, differentiate the bottom, which is just 1 over the bottom squared. I will proceed into expanding. However, I first notice that 2x plus 5 is a common factor, so I will take the 2x plus 5 out, and I'm left with 4 times x minus 3 minus 2x plus 5, close the curly brackets, over x minus 3 all squared, and this is 2x plus 5 times 4x minus 12 minus 2x minus 5, all of it over x minus 3 squared, and this further simplifies into 2x plus 5 brackets 2x minus 17 over x minus 3 squared. And then in part B, find the range of values for which f of x is increasing. We know that if we've got an increasing function, this means that the derivative is greater than or equal to 0. So increasing means that f dash of x is greater than or equal to 0. So we can see from the expression we've got here that the denominator can never be negative. So for the numerator to be positive, I start by identifying the critical values, those values that make the numerator 0, which are obviously the minus 5 over 2 and the 17 over 2. So it's a quadratic inequality. I solve this graphically. The minus 5 over 2 is here. The 17 over 2 is here. It goes plus, minus, plus. We want to be positive, so we want to be on the left or to the right. So the solution is that we are increasing for all values of x such that x is less than or equal to minus 5 over 2, or all values of x such that x is greater than or equal to 17 over 2. In 4II, we've got g of x is x root of sine of 4x, and we need to show that for a maximum point, we need tan 4x plus kx to be 0, where k is a constant to be found. So I will actually start by differentiating. We've got g of x is x times sine of 4x to the half. I'll be using the product rule here, so g dash of x, we differentiate the first, we get 1, we keep the second, sine of 4x to the half, plus keep the first. To differentiate sine of 4x to the half, we get the power down, we deduct 1 from the power times the derivative of the bracket, which will be 4 cos of 4x. This simplifies to the square root of sine 4x plus 2 times x times cos of 4x over the square root of sine of 4x. This is the expression for g dash of x. So I want g dash of x to be 0 as I'm looking at the maximum point, which means that the square root of sine 4x plus 2x cos of 4x over the square root of sine 4x must be 0. And I will multiply throughout by the root of sine 4x to get rid of the denominator. This leads to sine 4x plus 2x cos 4x is 0. The only way for tan to appear is for me to divide throughout by cos of 4x, which takes me to tan of 4x plus 2x is 0, which matches the form of the answer I was asked to give, my answer 2, so k is 2. Question 5, we need to take this equation here that involves tan of 2x cos x cos x squared, set t to be tan x, and obtain this quartic. So I will start. by saying that the double angle for tan 2x is 2 tan x over 1 minus tan squared x, and according to the substitution of t being tan x is simply 2t over 1 minus t squared. We also know that cot of x is 1 over tan x, which will be 1 over t. And finally, sec squared x is 1 plus tan squared x. So this will be 1 plus t squared. And so I can revisit the given equation and simply substitute. So we've got 12 tan 2x plus 5 cot x sec squared x is 0. So this will become 12 times 2t over 1 minus t squared plus 5 times 1 over t times 1 plus t squared is equal to 0. So we will proceed into simplifying all of this. We've got 24t over 1 minus t squared plus 5 times 1 plus t squared over t is equal to 0. The LCM here is 1 minus t squared times t. So I will multiply the first fraction by t to give me 24t squared, and the second one by 1 minus t squared to give me 5, 1 plus t squared, 1 minus t squared. And now I proceed in expanding. 24t squared plus 5 times 1 minus t squared plus t squared minus t to the 4 is 0. The minus t squared with the plus t squared, they cancel out. So we've got 24t squared plus 5 minus 5t to the power of 4 is 0, which simply means that 0 is 5t to the 4 minus 24t squared minus 5 as required. So this completes the first part of the question. And then part B, we need to solve for x being in degrees between 0 and 360, answers to be given to 1 decimal place. So we have this quartic here in terms of t, so I will start by letting w be t squared, which means that w squared is t to the 4. This will allow me to write the given quartic as a quadratic. So we've got 5w squared minus 24w minus 5 is 0, which factorizes into 5w plus 1 times w minus 5. So we get that 5w plus 1 is 0, or w minus 5 is 0, which means that w is minus a fifth, or w is 5. Well, w is t squared, so t squared is minus a fifth has to be rejected. It's not valid because something squared can never give you a negative result. And on the other hand, we've got t squared is 5, which means that either t is root 5 or t is minus root 5. Now t was tan x, so we've got to solve tan x is root 5 or tan x is minus root 5. The principal value will be shift tan of root 5, which gives an answer of 65.905, and therefore x is the PV plus 180k. And on the other hand, the PV is shift tan of minus root 5, which gives an answer of minus 65.905, and therefore x will be minus 65.905 plus 180k. Setting k to be 0 will give me the answer of 65.9, which is the only answer in the required range. Then I will set k to be 1 here and here. I get an answer of 245.9 and 114.1. And finally, I will put k to be 2 here, and I get 294.1, a total of 4 answers in the range between 0 and 360. Question 6, we've got f of x here. It's an expression that involves the modulus function. We need to state the coordinates of p, it's the coordinates of the vertex. We know that the vertex will be wherever the modulus expression is 0. So if we've got 2x minus 5 is 0, that means that x is 5 over 2. It also means that this is 0, and therefore f of x is simply 3. So the coordinates of p will be 5 over 2, 3. In B, we're asked to solve f of x is 3x minus 2. So I will actually go back to my diagram here, and I will start adding some information. So I will start by identifying the equation of the line segment here and here. So on the right hand side, it's 2 times 2x minus 5 plus 3, which simplifies into y is 4x minus 7. And on the left hand side, we've got y is minus 2 times 2x minus 5 plus 3, which simplifies into minus 4x plus 13. P was found to have coordinates of 5 over 2, 3. So in other words, the part that goes uphill, it's where the modulus behaved like a normal set of round brackets, and the part that goes downhill, it's where we had a negative sign introduced outside. Now, we are asked to solve the equation f of x is 3x minus 2, so I will be drawing a straight line that cuts the y-axis at a negative value, and it's less steep than this line here. This line has a gradient of 4. I'm drawing y is 3x minus 2, so there are obviously 2 distinct cuts, one with the line 4x minus 7, the other with the line minus 4x plus 13. These will give me the solutions I'm after. So in part B, I will be equating 3x minus 2 with a negative 4x plus 13, and 3x minus 2 with 4x minus 7. So I get 7x is 15, which means that x is 15 over 7. And on the other hand, I get 5 is equal to x. These two are the solutions for the equation f of x is 3x minus 2. And the last part C, given that the equation f of x is kx plus 2, where k is a constant, has exactly 2 roots, find the range of values of k. I will try to show you on an animated graph exactly what's happening here. So this is the graph here. In red, we've got f of x, the modulus graph, and in blue, we've got the straight line y is kx plus 2. If I start playing with k, you can see that we are playing around with the steepness of the line. So if I allow the animation to run, we can see that we've got one point of intersection. And then as we get progressively less steep, at some point we will be exactly parallel to the line there. So again, one point of intersection. But if we start being less steep, we've got 2 points of intersection. And then at some point, I will go exactly through the vertex, and I will be looking at a single point of intersection. So the solutions we're trying to get for k, in order to have 2 distinct cuts, is for us to be greater than the vertex and less than being parallel to the line there. So let's go back to the graph to draw the 2 limiting cases, and let's see how we can find k. So on the graph, I'm drawing the line y is kx plus 2 passing through the vertex P, and I will also be drawing the line kx plus 2 parallel to the line y is 4x minus 7, so having a gradient of 4, it will probably look something like this. So these two are parallel. This is y is kx plus 2 as well. So we know they must be having the same gradient. So here we conclude that k must be 4. Let's try looking at this case here to find the value of k. So we have the line y is kx plus 2. We know that when x is 5 over 2, we need y to be 3. And therefore I substitute 3 is 5 over 2k plus 2. Multiply throughout by 2, I get 6 is 5k plus 4. So we get that 2 is 5k, and therefore k is 2 over 5. So we can now conclude that k must be between 2 over 5 and 4 for 2 points of intersection. In question 7, we need to show that the x-coordinate of point P here lies between 0.8 and 0.9. I will actually start by saying let f of x be exactly the expression for y, which is 2 cos of 3x minus 3x plus 4, and I will be substituting f of 0.8, and this gives an answer of 0.1252, which is greater than 0, and f of 0.9, which gives an answer of minus 0.5081, which is less than 0. Remember, you have to be in a radian mode. You substitute into the expression, you get one positive, one negative, and you say change of sign, and f of x continues, hence root exists. So we can say hence alpha lies between 0.8 and 0.9 as required. So this completes the first part. It's imperative you mention the continuity, otherwise you will be penalized. Then in part B, we need to use the iteration formula given here, starting with x1 is 0.8 in order to find x2, x5 to 4 dps. So starting with x1 being 0.8, I will say that x2 is 1 over 3 arc cos of 1.5 x1 minus 2, and this gives an answer of 0.8327. And if I continue in a similar fashion, I'll get x3 to be 0.8068, x4 to be 0.8271, and x5 to be 0.8110. And finally, C, we need to use calculus to find the x-coordinates of Q and R. So Q and R are minimum points. We need to be careful here. We will find the derivative. We will set it equal to 0 because we are looking at turning points. However, we need to be careful that this is also a turning point. This is a turning point. That's a turning point. So when we come to solve the y, the x is 0, we want the first and the third positive solutions, because the second positive solution will correspond to the local maximum here. So y is 2 cos of 3x minus 3x plus 4, which means that the y dx will be minus 6 sine of 3x minus 3, and I will set it equal to 0, which means that minus 6 sine 3x is 3, so sine of 3x is minus a half. And then we start by finding the principal value. It's shift sine of minus a half, which turns out to be minus pi over 6. And therefore we have that 3x is the PV plus 2 pi k, or 3x is pi minus the PV plus 2 pi k. I will divide throughout by 3 to get minus pi over 18 plus 2 pi k over 3, or x is 7 pi over 18 plus 2 pi k over 3. If I set if I set k to be 0, this will give me a negative answer. I don't want it. If I put k to be 0, I get 7 pi over 18. That's the first positive solution. If I set k to be 1 here, I get 11 pi over 18. And if I set k to be 1 here, I get 19 pi over 18. We did explain that we are looking for the first and the third positive solutions, and therefore we conclude that beta is 7 pi over 18 and lambda is 19 pi over 18. In question 8, we need to find the exact value of this integral. Now the integral of 2 over 3x minus 1 is a standard integral, as it gives us an answer that involves ln. So it's going to be 2 ln of 3x minus 1. And I also need to divide by the derivative of the inside. And I'm integrating from 3 up to 42. I will substitute the 42. I get 2 over 3 ln of 3 times 42 minus 1 minus 2 over 3 ln of 3 times 3 minus 1. So this leads to 2/3 ln of 125 minus 2/3 ln of 8. So we need to give our answer in its simplest form, so we're not yet done. I can see that 125 is ln of 5 to the 3 minus 2/3 ln of 2 to the 3. So the 3 can come down. It's 2 over 3 times 3 ln 5 minus 2 over 3 times 3 ln 2. Obviously, the 3 will cancel out in both cases. I get 2 ln 5 and 2 ln 2, which becomes ln of 5 squared minus ln of 2 squared. It's ln of 25 minus ln of 4, so this is just ln of 25 over 4. And then in II, we need to express h of x in this form and then proceed in integrating h of x with respect to x. I will start by doing long division. So we have 2x cubed minus 7x squared plus 8x plus 1 to be divided by x squared minus 2x plus 1. So we're always trying to match the highest order term on the left. I start with a 2x, so it's 2x cubed minus 4x squared plus 2x. I deduct everything. I get minus 3x squared plus 6x plus 1. So minus 3 will give me minus 3x squared plus 6x minus 3. So I've got a remainder of 4 here. This means that h of x can be written as 2x minus 3 plus 4 over x minus 1 all squared. That's x squared minus 2x plus 1. So the integral of h of x with respect to x will be the integral of 2x minus 3 plus 4 over x minus 1 squared dx. I will write this as the integral of 2x minus 3 plus 4 times x minus 1 to the minus 2 dx. So let's increase the power by 1, divide by the new power, minus 3x plus 4, x minus 1, I increase the power by 1, I divide by the new power, I divide by the derivative of the bracket. I need to put a plus c as this is indefinite integration. So this simplifies to x squared minus 3x minus 4 over x minus 1 plus c. In question 9, we start by expressing 5 cos theta minus 4 sin theta in the form of r cos theta plus alpha. So I'll be using the addition formula here. I've got 5 cos theta minus 4 sine theta to be expressed in the form of r cos of theta plus alpha. So this will be r cos theta cos alpha minus r sine theta sine alpha. Now we'll be comparing the cos theta terms. So 5 cos theta will be equated to r cos theta cos alpha, and then the 4 sine theta with the r sine theta sine alpha. Notice that the negative sign is common and cancels out. So we can conclude that 5 is r cos alpha and 4 is r sine alpha. So 5 over r is cos of alpha and 4 over r is sine of alpha. It makes sense to draw a right angle triangle here. So we've got alpha here, the cosine is adjacent of the hypotenuse, the sine is opposite of the hypotenuse. So Pythagoras will give me that r is 4 squared plus 5 squared square root, which is root of 41, and tan alpha is 4 over 5, which means that alpha turns out to be 0.675, to conclude that f of theta is root 41 cos of theta plus 0.675. The curve y is cos theta is transformed to the curve y is f of theta. And given that the first transformation is a stretch and the second is a translation, we need to describe fully the transformation that is a stretch and then the transformation that is a translation. So if we think about it, the stretch here is along the vertical scale factor of root 41. This simply means that we multiply all the y values by root 41. So it's a stretch along the vertical. We need to specify the direction, and then we need to provide the scale factor. So scale factor root 41. And then for the translation, it's along the theta direction, it's along the horizontal, it's 0.675 units to the left. So we say translation by 0.675 units to the left. This describes the two transformations that take place to take us from cos theta to f of theta. And then in C, given that g of theta is 90 over 40 plus f of theta squared, we need to find the range of g. It actually makes sense to try expressing g of theta in terms of the cosine we obtained. So this is 90 over 4 plus f of theta squared, which is 90 over 4 plus the root of 41 cos of theta plus 0.675 squared. Now we know that the f of theta being root of 41 cos of theta plus 0.675 has a maximum at root 41 and a minimum of negative root 41. This is simply because the cosine of any angle varies between -1 and 1. So root 41 of any times the cosine of any angle will be between minus root 41 and root 41. So f of theta is between minus root of 41 and root of 41. So if I square it, I will certainly be less than or equal to 41, and I will surely be greater than or equal to 0, because anything squared is always non-negative. Now, if I add 4, I get that 4 plus f of theta squared will be between 45 and 4. So if I reciprocate this, if I do 1 over 4 plus f of theta squared. You will see that we've got an interchange. When I reciprocate the 45, it will come on this side, and this will come on this side. So it's gonna become 1/45 and 1/4. In order to see this, I'll give you a quick example. If you agree that 2 is less than 3, then if I take the reciprocals, then 1/2 compared with 1/3, the 1/2 is greater. So when I do 1/, I change the inequality direction. Now, instead of changing the inequality directions, I change the positions. So the reciprocal of 45 now appears on the left, and the reciprocal of 4 appears on the right. So I'm trying to reconstruct pretty much the expression for g of theta. The only thing missing is to multiply throughout by 90. So 90/45 is less than or equal to 90/4 plus f of theta all squared, which is less than or equal to 90/4. And therefore we conclude that 2 less than or equal to g of theta less than or equal to 22.5. In other words, the range of g of theta is between 2 and 22.5 inclusive.